Cyberjaya 10 Mosque. The Cyber 10 Mosque in Selangor, Malaysia embodies a return to the fundamental principle of mosque design, transforming it into a multifunctional community center that seamlessly blends modesty and abundance. Drawing inspiration from earlier mosques in the region, such as Masjid Kampung Laut and Masjid Lebuh Aceh, the structure is meticulously tailored to its surrounding, climate, programming, ritual practices, and traditional craftsmanship. The result is a building that resonates with the community itself. As a center of excellence, the Cyber 10 Mosque aspires to be a comprehensive hub for learning, living, and spiritual rejuvenation. Its expansive green buffer and park, dialysis center, multi-purpose room, open courtyard, and serene jenazah managing room and garden reflect a holistic approach to community well-being. Beyond its conventional role as a place of worship, the Cyber 10 Mosque seeks to integrate with the community, addressing both communal and social needs. This integration not only uplifts the community but also engages it in a meaningful manner. The Cyber 10 Mosque, situated in Selangor, Malaysia, has a large enough interior to hold 3,300 worshippers. The mosque, which has a 20,234 square meter footprint, was constructed in 2014 and was designed by Juratera's Design Workshop. The Cyber 10 Mosque embodies a skillful fusion of superior architectural design, cultural awareness, and a commitment to meeting the varied requirements to its local populace.
Foundation system. A shallow foundation, as a fundamental component of structural engineering, refers to a type of foundation that is constructed near the surface, effectively transmitting building loads to the underlying soil. Specifically, within shallow foundation, the spotlight turns towards strip foundation. The strip foundation is characterized by its ability to distribute structural loads horizontally over a broader expanse, often resembling a continuous strip of footing. This strategic distribution of a load serves to mitigate the impact on the underlying soil, preventing excessive settlement and ensuring the stability of the structure of Masjid Cyberjaya School. Construction process of strip foundation. The construction process begins with the excavation stage, during which the specific space for the strip foundation is carefully removed. The digging depth is determined based on the structural needs and soil conditions to guarantee a solid and safe foundation. Following the excavation process, the arrangement of the foundation begins to form on the cleared site. Accurate measurements and alignment are the highest priority during this phase, as they must line up with architectural and engineering drawings. Next, the dark area is filled with steel bars, precisely placed to meet engineering criteria. The purpose of this reinforcing mesh is to increase the tensile strength of the foundation, making it capable of withstanding the heavy loads given by the steel structures of the mosque. Once reinforcement is in place, the construction process proceeds to the installation of formwork, which acts as temporary mold to shape the concrete into the desired structure. The construction process to culminate with the pouring of concrete into the formwork. This stage comprises the meticulous placing and positioning of concrete, ensuring a uniform distribution and compression around the reinforcing. The concrete mixture is to fulfill specific structural demands and environmental circumstances, increasing the foundation durability and lifespan. After pouring the strip foundation, undergoes an important phase of curing, allowing the concrete to achieve its maximum strength.
The overall Masjid Cyberjaya 10 Mosque is built using a two-way system of beams and steel framing structure, making it open and spacious. The fundamental component of the praying hall is composed of a universal column measuring 200 x 200 mm and an I-beam measuring 300 x 400 mm. The major four cores in the center are made up of four columns each to support the three-tiered roof truss. There is a total of 36 columns with a span of 8.5 meters column to column. Following that, the Serambi are built in a simple corridor design with a slanted roof to cover it. The column used is IHS, which is rectangular hollow section in the size of 100 x 50 mm with a span of 6.5 meters column to column. To create a stable and efficient structural system for Masjid Cyberjaya 10, various types of joints and connections are used to assemble the structural members. The choice of joint and connection type depends on factors such as the type of structure, loads it will bear, architectural requirement and construction methods. The connecting mediums used to connect all the structure is by using welded connections and bolted connections. These connections are also known as rigid connections. Rigid connections are essential for resisting lateral and rotational forces, providing stability to a structure, and facilitating the transfer of loads. A steel plate is welded to the end of the beam, and it is then bolted to the supporting column. This configuration provides a rigid connection and allows for the transfer of bending moment between the beam and the column.
Wall systems. Walls are fundamental components in a building that serve as a partition to differentiate space. The Cyberjaya mosques are using several types of wall system with different materials. Brick wall system. Exploring traditional construction methods, the Cyberjaya mosque incorporates a brick wall system in strategic areas of its architecture. The brick wall system, known for its visual appeal and structural integrity, involves arranging bricks in this mosque. The brick wall system is selectively applied, notably in the front part of the main prayer hall. This solid brick wall acts as a partition, blocking the front view to allow an uninterrupted prayer experience for the imam. Additionally, the brick wall is utilized in the ablution and toilet areas, serve as partitions and providing a distinctive environment with added aesthetic value. While not applied throughout the entire building, the use of the brick wall systems enhance both functionality and visual appeal in the areas of the mosque. Next is glass wall panel. Incorporating innovation in architectural design, the Cyberjaya mosque feature glass wall panels as a prominent element in its main praying hall. These panels, made mostly of glass, provide transparency and serve both aesthetic and practical purpose. The main prayer hall is uniquely surrounded by a glass wall on the side and back, designed as sliding or folding system for flexibility in opening and closing spaces. The foldable glass doors serve as the entrance, and the glass louver windows provide ventilation into the space. This design choice allows for a seamless connection between the indoor and outdoor spaces, maximizing natural daylight and reducing the needs for artificial lighting. The strategic use of glass walls also enhance air circulation, minimizing reliance on fans and air conditioning. Lastly is non-load bearing wall. Non-load bearing walls. This wall plays a crucial role in providing flexibility and ease of construction. Essentially acting as partitions, they don't support the building's structural weight, making them quicker and simpler to build. At the Cyberjaya mosque, non-load bearing walls are strategically utilized, notably in the ablution and toilet areas where they act as partitions without bearing structural loads. The main prayer hall also features non-load bearing walls, primarily constructed with glass. As these walls don't carry the roof's load, they allow for design flexibility and are supported by steel columns and beams, emphasizing the practical application of non-load bearing walls in specific areas of the mosque.
The roof of Masjid Cyberjaya 10 is a modern structure that uses 3-tiered roof design with the roof slope at 30-degree angle at the main prayer hall, which uses structural steel roof framing and finish with metal deck roofing. Subsequently, the Serambi, spillover area, open court and corridor are constructed in a straightforward corridor layout, including a sloping roof for protection. At Tier 1 roof, the purlin were 50 x 50 mm with 600 mm to center, galvanized steel finish with white paint, and the rafter was 200 x 200 mm with 1200 mm to center. Then it is supported by supporting roof beam at size 600 x 200 mm to support the rafter and the purlin. However, at the Tier 2 and the Tier 3 roof, the purlin size and space remain the same, but the rafter and the roof beam size decreased. The rafter was 180 x 180 mm with 1200 mm to center. Then it is supported by the roof beam at 280 times 180 mm to support the rafter and purlins. There are skylights at the third tier of the roof to give the natural lighting into the main prayer hall. Then, the rafter at the tier 3 roof was connected with a bolted connection. Next, the serambi are constructed in the form of a straightforward hallway and they are covered by a simple slanted roof with span of 6.5 meter from one column to another column. The column that is utilized is a rectangular hollow section RHS column that measured 100 times 50 mm with purlin, 50 times 50 mm spacing, 600 center to center, finished with metal decking.
Assalamu alaikum. For the roof finishing, designing a mosque with a metal finishing for its roof introduces a contemporary and durable element to the architectural landscape. In addition to providing structural strength, the use of metal, typically steel or aluminum, allows for complex and creative designs that improve the mosque's visual appeal. The sleek, metallic finish can be used to create a harmonic blend of creative and cultural value in both classic and modern architectural form. For the floor finishing, there are 4 different types. First, for the toilet finishing, ceramic was used, which blends design and utility. It's a great option for bathrooms. Ceramic tiles, which are well known for being water resistant, produce a surface that is strong and simple to maintain. Second, carpets as the finishing floor for a mosque creates a warm and inviting atmosphere. In addition to improving the sound quality and creating a calmer worship space, carpets are comfortable underfoot. Third, mosque's concrete floor finishes combine style and functionality. Concrete overlays can be customized due to their adaptability, and chrome or trolled finishes can be used to achieve a desired texture. Concrete's smooth, cooled surface improves the atmosphere for prayer. Fourth, granite floors in a mosque offer enduring elegance and durability, elevating the squared space with a refined atmosphere. Customizable colors complement the mosque's style, and granite's durability withstands heavy foot traffic. The cool, silky surface adds comfort, symbolizing strength and endurance for a serene space for prayer.
To sum up, an in-depth study of the steel structure of the Cyberjaya 10 Mosque demonstrates how well structural strength and creative design are combined. Steel is strategically used to provide durability and strength, while also enabling elaborate architectural details. The project is a model for contemporary construction methods, demonstrating the harmonious coexistence of engineering perfection with aesthetic grace. The most successful construction highlights the unmatched benefits of steel and establishes it as a pillar for environmentally friendly, robust, and aesthetically pleasing architectural projects. The Cyberjaya 10 Mosque, which harmonizes form and function, is a striking example of how steel can revolutionize the building industry and shape the future of construction.